Hi, in this video I would like to explain you how to create a soft patch for a Ethernet DMX converter. To better explain you what a soft patch is, let's take a real example. In this setup, we would like to control this matrix of RGBW moving light from this lighting console using IP address 2001 or from this media server using IP address 2002. Both the console and the media server are connected to a GHz switch, and from this GHz switch we connect a Ethernet DMX converter which will provide DMX to all moving lights. All moving lights are patched inside the lighting console by using ArtNet Universe 1 to 8, while on the media server all RGBW cells are patched inside the media server by using protocol SSEN from Universe 1 to 8. By looking at the DMX chart of the moving light, we can see that from channel 1 to 16, all the channels are dedicated to control, such as pan, tilt, beam shape, and so on. And from channel 17 to 116, these are RGBW parameters. The idea, and to make it simple, is to patch the RGBW cells into the media server the same way they are patched into the console, what we call a one-to-one patch. The main goal of this setup is to be able to control remotely who is in control of all the RGB cells. In the console, we will patch a specific channel called the trigger channel on a specific universe called the trigger universe, in our example ArtNet Universe 10. By sending this command to the node, we will be able to select who will be in control of the RGBW cells, which means we will be able to create a crossfade between the console and the media server. This is how to do it. Let's open the demo project. And let's start from the profile we have previously created. I will start with the first output. In our case, it will be obviously an output. We don't set the protocol yet, and we don't set a universe number, and we won't be using RDM as well. Now, what we want to do is to create an IP merge. So into the IP merge column, select Custom, and now click on the Patch button. Here, we can set the IP address of the first source. In our example, this is 2001, the lighting console. The second source is the media server, which is IP address 2002. As we have seen, the console will be using ArtNet 1 to 8, while the media server will be using StreamASN 1 to 8. So for the first outlet, we will set both protocol and both universe number. As you can see on the top, there is some other menus. You can access those menus either by sliding the top tray or just using the arrows on the left and on the right. As we have seen, channel 1 to 16 are dedicated to control. So we will first create a first type of fixture called control. We know that we can't patch more than 4 moving lights on one DMX output. We will start at DMX address 1, and we know that the total number of DMX channels used by the moving light is 160 channels. This is what we call the total offset. For easier DMX patching, we could actually use 120 just to use an easier number, but in my example, I will be using the real DMX addresses. For this first part, we know that the moving light uses 16 channels for the control part. Now, the software has automatically created 4 control parts, which is control 1, 2, 3, and 4 here. With this menu, you can select what to see or not. In my example, I can hide the remaining channels, and I will only see the control part. As we said, this control part will be only controlled by the lighting console. So I will select the S1 only merging policy. Now let's create a secondary fixture called RGBW cell. This one will be starting at channel 17, the channel right after the last control channel actually. There will be 4 groups as well. It will be using a total offset of 160 channel. Again, that's the total footprint of the moving light. And this will be using 100 channel, which is the total amount of RGBW channel for the RGBW cells. Now you can see the 4 groups of RGBW cells created. And in our example, we want to control these RGBW cells either from the lighting console or from the media server. So we'll be using the crossfade merging policy. And this crossfade will be remotely controlled by trigger channel 1. Again, if I unhide the offset, we can now see the RGBW cell, the control part, RGBW cell, and so on. If you want to have a look from the control point of view, simply select control, and you will see the control part, the RGBW cells, the control part, and so on. Your crosspatch is ready. Now, this is my base configuration. Select the other menu here to copy this configuration to all the other ports. So from port 1 to port 2 up to 8 and press copy. Now the last step is to assign the right universe number for each outlet. And so on. Next step is to enable the trigger to be able to remotely select who is in control of the RGBW cells. As we said in our example, the trigger universe will be universe 10. So we set universe 10, we select ArtNet, and we can even specify the IP address of the source that will be sending this trigger channel. Last step, you can set here the DMX frame rate, the way the box output DMX on all the connectors, and also select the verbose level, as explained in the previous video. Your configuration is ready. Press Save to save your soft patch. Thanks for watching.